Okay, in today's lesson, we are going to learn strategies to simplify rational expressions and how those differ from equations. So the first thing I'd like to stress is just the difference between an expression versus an equation. An expression might look like this, but an equation is going to contain an equal symbol. Directions for an equation, we solve equations. So you want to find all possible x's that make that true. And for an expression, we're going to spend time simplifying our expressions. The reason we want to simplify is so that as we learn algebra calculus, you don't want complicated calculus. So if you have complicated algebra, you want to simplify the algebra, because simplified algebra going into a calculus kind of application or problem will make your calculus much easier. One of the two main ideas that I see kids make is we don't add an equal whenever we're simplifying an expression. So I will try to make a concerted effort not to put that in your notes, even though often we use equal to mean equivalent. And when we do equations, remember whatever you do to one side, you do to the other. So we're going to have separate strategies for expressions versus equations. So as we move through the lesson, just be cognizant of those differences. Another huge concept that I want you to understand is when we talk about the quotient of two polynomials as a rational expression. So again, an example, x plus 6 over x squared minus 1 is a rational expression. That when we use this idea of canceling, that word canceling is not wrong, it's not incorrect. I want you to understand what it means to cancel. So a fraction or a rational expression is in simplest form if its numerator and denominator have no factors in common aside from plus or minus 1. So if you notice the example I have here, a times c over b times c, the c's can cancel because this has to do with the multiplicative identity. Yep, those things you learn in Algebra 1. And the multiplicative identity says you can take any number, multiply by 1, and it stays itself. It stays equivalent. So if I am reducing this expression by 1, then it is a times c over b times c is equivalent to just a over b. Let's put in some of our favorite numbers just to exemplify that. Let's let a be 2, c be 3, b be 4, c is still 3. By multiplying fractions out, the numerator is 6, the denominator is 12, and I get 1/2. Or I could cancel the 3's. I'm left with 2/4, which also reduces to 1/2. So those are equivalent statements. The statements you have to be careful about is if I have 2 plus 3 over 4 plus 3. And sometimes I will see students go, oh, we've got a 3 here and a 3 here, so I cancel that out. I get 2/4, which is 1/2. Actually, what you had is 5/7 when you do the math. Those are not equivalent statements, so you need to be careful about the operation. This is addition. The identity with addition is 0, and 3 over 3 is not 0, so that is an illegal way to cancel. When we talk about the multiplicative identity, then that means that you need to have your numerator and denominator factored. So you're looking for a multiplication operation, not an addition. So often I will see kids write x plus 5 over x minus 7. They see that there's an x on top, they see that there's an x on bottom, and they call it 5 over negative 7. But that is incorrect canceling because it's not over the operation of multiplication. So please make sure you understand what it means to cancel, how that's related to the multiplicative identity, and that you're reducing your expression by the number 1. Let's simplify a rational expression. Your basic directions are to factor and then cancel. So when I look at letter A, the numerator, it does have a greatest common factor, which is our first little factor. Just be careful that you can choose to pull out a positive 4 in the numerator, or you can pull out a negative 4. It is advantageous in this problem to pull out a negative 4, and if I turn that around, because then I get a common factor that is the exact same in the numerator and denominator. This is the number 1, so I can cancel, and always take a couple seconds to just kind of self-talk. I'm canceling canceling because I'm reducing by the number 1, which is the multiplicative identity. So if you're ever stuck in the future, if you can do it or not, that self-talk will help you. Here's another way that you can informally check your answer. It's not a foolproof way, but pick your favorite x. Let's say we want x to be 2. If I plug it into the original, I'm left with 8 over, that would be 4. Get with the program now. I'm left with 4 over negative 1, and that is equivalent to what I got down here. I could pick a different number. Let's say x equals 0. That would give me 12 over negative 3, still equivalent. That's an indication that your original that you started with and your simplified answer are both equivalent. Let's look at B. First rule of factoring is a GCF. There is none in the numerator. I have 3 terms, so I'm going to reverse FOIL it. In the denominator, there's no GCF. There's 3 terms. I'm going to reverse FOIL it. And what you notice here is that we don't have any common factors. This is mildly annoying that you feel like you've done work for no reason, but whenever you have a problem, you do need to look and see if it's to factor and cancel, to remove any factors that are common to the numerator and the denominator. Your final answer in this case could be left as the highlighted equation, the original. I would encourage you to always factor and keep things in factored form, because that would allow you to just make sure that you check for any of those common factors. The last question we did in class today was problem A, and take 15 seconds before you do a problem to step back and ask yourself what the heck I'm doing. Please notice the operation. On your test, there aren't going to be just multiplication problems together, just division, just subtraction. They're going to be mixed up. The directions are going to say perform the indicated operation, period, simplified, period. So you want to make sure that you are aware of what you're doing. And when I multiply fractions together, I just multiply the numerators together. And then I multiply the denominators together. Now you have an expression, a little bit more complicated than when we done it on the first slide, but basically the idea of this factor cancel is going to, that's what we do at this point. We have one fraction. So my numerator factors into x plus 2y times x minus y times that monomial of x over x squared times x plus y. And then the trinomial factors into x plus 2y, x plus y. Notice how x plus 2y has a common factor in the denominator, so we reduce by 1. X minus y does not have a common factor, so it stays in the numerator. But then I have a monomial of x, and I have a monomial that's x squared. Remember, x squared means x times x. So you do have a common factor of an x in the numerator and the denominator to reduce by. So my final equivalent simplified answer is x minus y over x times, and I can write this more efficiently as x plus y squared. Another way that you can go about doing this problem, I just wanted to show you the operation first. Some students will factor like right above it. So this is the way that they show their work. And then they just remember that, ooh, that was incorrect canceling, sorry about that. Then they cancel this way. And if that's something that works out for you, that's great, but ultimately this is what you should get as your final simplified answer.